Hello, this is Kanaya. This is my gift to future students. This is the AP CALC Museum of Minecraft. Yay! This is the limits and continuity exhibit. I don't know. Yeah. So the red line represents a graph, and the dark bricks, those are the X and Y axes. Axi. And yeah, there's words, and you're supposed to go along the graph, like your little dot, and this is a line, and you're exploring that line. How crazy! So this part of the graph is continuous. There's no holes, and as x approaches 5 from both the left and the right, y approaches 3, and so since it's the same, the limit exists. This is a jump discontinuity, and this is a jump discontinuity, so as x approaches 8 from the left, y is 3, and as x approaches 8 from the right, y is 5, so since those numbers are different, it's a discontinuity, and at either of these points, there's either opened hole or opened point, open hole or a closed point. And this is a removable discontinuity, so the line, it will look continuous but have an opened hole at this point, and in place of that opened hole, the point exists at somewhere not along the graph, which is, in this case, it's 2 blocks above the graph. So the limit exists because x approaches the same number from left and right, but f of that point, which was f of 10, was not the same as what the limit approached to. Okay, and then this is an infinite discontinuity. It goes on forever. There's a y asymptote or an x asymptote, and yeah, it's discontinuous. Okay, yeah, and then you get a little prize at the end. I got an apple, a regular one. It's so boring, but there's better prizes if you go through the thing. This is just me looking around, showing you things. The next part was probably my favorite to make because the little arches at the top. I thought they were pretty. And so this example uses left Riemann sums to estimate the area under the curve. This can be helpful for finding a particle's position along the graph of the antiderivative of this graph. So the gold graph right here shows p prime of t, which is the velocity of the particle in the x direction in relation to time. And we're going to say when time is 0, the x position is 3, so x equals 3. That's our initial value. That's where we're starting. So a common question they may ask you is to find the x position of a particle, and they can give you a graph or equation of the velocity in the x direction, and we're going to use the integral or the area under the velocity graph, and that'll tell you it'll really tell you the displacement of the particle, because it can either be negative or positive velocity. And so yeah, so the answer to the question is of what is the x position of the particle at t equals 3 is the initial value plus the integral from 0 to 3 of p prime of t. So in these terms, it would be 3 plus the integral from t equals 0 to t equals 3 of 1 negative 1/4 t squared, whatever that was. Yeah. And so when the slope of the graph is positive, it should say, and the graph itself is concave down, a left Riemann sum will be an underestimate of the true area under the graph. As you see, this part of the graph, the slope, it's positive, it's going up and to the right, and there's holes under those little Rubin stones. Okay, so let's create a new scenario where the gold graph is the original graph, f of x. This graph would be the derivative of the graph to the right. This would be f prime of x. And so you see here the f prime slope is negative. It's going down and to the right. And so that means f double prime will be negative and under the x-axis because, yeah, it's the slope of the previous graph. So this is f double prime, and yes, and since f double prime is negative, the first graph, which is now f of x, is concave down. So that's why it looks like a frowny face. And so, yes, this is... Hold on, I gotta replace this block. It says bite. So either way, this is... acceleration is -2. So in a scenario with speed and moving and everything, the car or whatever the object is slowing down. Oh wait, no, sorry. It's a slowing down at a slower rate than it's at a decreasing rate. No, I don't know. Disregard everything I've said. Well, that part. Anyways, so this graph represents a regular parabola. Yes, and this dark line is its tangent line. So a tangent line is a line that, one, it tells you the slope at a specific point in point slope form, and two, it only touches a single point. So only touches, in this case, it would only touch the vertex, and then if it was like a point along the curve, it would still only touch like that one point. Yes. So that's a tangent line. And that's f of x. I'll show like a more accurate picture. Because Minecraft is, yeah, pixely. And so this one is the derivative graph of the previous thing I just showed you. And it'll tell you the slope at any point of x. And this is the derivative of that graph in the middle, right there. Oh, I think I showed you these signs. If I didn't, there those signs are. Oh my gosh, an ally. They're so cute. So, say the first graph was -x squared, even though it's not. Just say it is. The derivative would be -2x, and then the derivative of that derivative would be -2. And I'll explain how that works in a second. And you can read those graphs if you want. I mean, those signs. Turns out I already showed the trick. It's the signs in the middle. I just forgot to read them. So, yeah. I put like a little notice because I realized. Yes, this is the exhibit. That's nature. You can go out and explore after this. I put like pits of lava, so if you're in like survival mode, you can die by stepping into the lava and respawn at the bed up here, because this thing is floating. So here's the next exhibit. So this exhibit, I named it Broken, because everything looks broken, because that's how my brain felt when I first learned it, but it really got like better. And yeah. And so this one, you take a graph. Wait, first off, this is the disc method exhibit. And this is when you take a graph and the area under it and rotate it along the x or y axis. Axi, I don't know. And it makes a shape, and then you find the volume of that shape. Wow, so that's after rotation. So that's before I took strips. And yeah. The orange blocks represents the graph up there. The disc method takes multiple slices of the area under the curve and rotates it around the x or y axis. And it adds all those tiny infinite cylinders, that it makes after rotation up, and then all those tiny cylinders, eventually, as you move towards infinity, the shape will get smoother, and you can find the volume of that shape using integrals. And just a reminder, the slices that you take as shown are perpendicular to the axis of rotation. So I have up and down strips, and yeah, that's how they rotate. The back is part of the like exhibit thing, Broken, and I wrote like a little message. Whee! I hit the block. So that's the axis. So this is like the inside, and it says hi. I made the walls by like melting lava and then cooling it with water. Yeah, most of the walls, just some of it. And so up here we have the same graph, but we're gonna find the shape when it's rotated around the y-axis. And so for this, we need perpendicular strips, so the strips go side to side. And since this is basically on another axis, you have to turn the equation that you use in terms of x. So the original, here I'm showing you how that graph of y equals, e to the x, how it looks when it's swept across in a circular motion across the y-axis. And so, I don't know what I was saying, but so the blue strip represents that's a dy strip, and it's gonna be rotated. It's like one of the infinite strips that are rotating. So the cylinder concept from that graph over there still applies, but this one is cut in half. So where a cylinder would usually be pi r squared times height, this one is just the same thing times 1/2. So you do 1/2 times pi times the integral from a to b, whatever those numbers are, of r squared dy. And this time r is going to be the same as the x equation, because you see this one r is in terms of like the y equation, y equals e to the x, but then this one over here, you have to switch it and make it x equals square root y. And so you basically flip the OG equation inside out, cause yeah. Okay, I'm done. That's it. Bye.